Hi grade 11s, now that we've done levels 1 to 3, hopefully we're feeling really comfortable with the basics of trig equations. And so we're stepping up to level 4 now, which is the first time trig equations become a little bit interesting. Now having said that though, these are definitely my favorite types of equations are level 4. So let's have a look. Question 1 says solve for theta in the following equations. Now don't forget that our first step so far has been isolate the trig ratio. So the moment I look at this particular question, I see 2 cos squared minus cos theta, and I'm like, how do I isolate the trig ratio if the trig ratio is in multiple positions? So notice that this is different to the previous examples, because in all the previous examples there's been one trig ratio. So I've just written myself a note there that that's the thing I must look for. My first kind of step is always, can I isolate the trig ratio, which so far has worked. But in this example, there's more than one trig ratio. And so when there's more than one trig ratio, this is something along the lines of, let me say instead of 2 cos squared, let me say 2x squared minus x is equal to 0. So notice it's not only that there's more than one trig ratio, it's also that it's quadratic. So this was almost when we started to transform in grade 9 between doing linear equations and quadratic equations, because in linear equations it's always isolate the letter, and in quadratic equations hopefully remember the key. The key in quadratic equations is to factorize. So in the future our first step is not going to be isolate the trig ratio. Our first step is it quadratic? In which case I'm going to factorize. If it's not quadratic, I'm going to go with isolating the trig ratio and go down the pathway that we've been doing so far. Now let's have a look. If we factorize here, if you struggle to factorize with trig, literally change the question on your question paper to 2x squared minus x, and then think about how you would factorize it. You would factorize this as take out a common factor of x, and then you would have 2x minus 1. So literally write that on your question paper, because now I know that I'm taking out a cos theta, because in my analogy x represented cos theta, which leaves me in the brackets with 2 cos theta minus 1. Now this is fairly kind of a familiar territory to us, because we've been solving quadratic equations for ages. So now either cos theta is going to equal 0, which is our first equation, or 2 cos theta minus 1 is going to have to equal 0. So once I realize it's a quadratic, I almost solve it like a normal quadratic equation. But at this point, I can now go back to solving my normal trig equations, because now both of these are the type of trig equations we have been solving in like level 1. So these are now 2 easy trig equations. So how do I solve this particular equation here? I don't forget that I shift cos of 0 and I get 90 degrees. And don't forget that I always write plus k360. K is an element of integers. However, we need to have the second solution. And the second solution is that this could be plus 90 or this could be minus 90. Now, how do I know that? I know that because this is a cos equation. So don't forget that cos is plus or minus. So there we go, that's the one solution. Now I'm going to divide my page in half here. My first step in a normal trig equation is isolate the trig ratio. So I take over the 1, and then I'm going to divide by 2, so I get a half. Now, as per usual, I shift cos a half, and I get 60 degrees plus k360. K is an element of integers, and don't forget that it's 2 solutions. So it's the positive 60 and the negative 60. So that gives me the 2 solutions. So basically, this was actually from a trig perspective, this was a very easy equation. So it was almost like a little bit of algebra in terms of the factorizing, and then 2 fairly easy equations, which is why these are my favorite, because they definitely look more complicated than they are. So there actually are 4 solutions for this equation. Right, let's try another one. So question B, my first question would be, is there more than one trig ratio? And in this case there's not. However, what do you notice? It's quadratic. So actually our first question is now going to be, is it quadratic or is it linear? So the answer to that question is either going to be yes or no, and then we will proceed in different manners. So if the answer is yes, we've learned that our first step then is to factorize. So if I look at this particular question, there's only two terms and there's no common factor, and so my thought is this a dot? And it is a dot, so it's almost exactly the same as 4x squared minus 1, which would factorize to 2x minus 1 and 2x plus 1. Instead of saying x though, my x is actually sine theta. So it's 2 sine theta plus 1 and 2 sine theta minus 1. Now my next step would be, from my factorized version, I'm actually going to make two equations, because literally doing a quadratic normal equation, now either I'm going to have the fact that 2 sine theta plus 1 is going to have to equal 0, or I'm going to have the fact that 2 sine theta minus 1 is going to have to equal 0. So I'm literally creating two equations. Now once I've got those two equations, I'm going to solve as normal, because these are now, so let me just correct my spelling there, solve as normal, because these are now two very standard, linear type equations. So in this example here, I'm going to take the 1 over, so it's actually negative 1. I isolate sine theta, which was my first step in my level 1, 2, and 3 equations. Then I'm going to shift sine. So remember that sine has two solutions and they are written separately. So shift sine of negative a half, and I get negative 30 degrees. And of course I mustn't forget my plus k360. And even if I was going to now solve a bit more for theta, which I don't have to in this case, always set up your second solution first. Now I wouldn't actually bother showing any working, but it's 180 minus that angle, which is 210 degrees. I wouldn't show any working, but just because this is a note, where does that come from? Don't forget that the second solution for sine is 180 minus the angle. So I add my plus k360 and I'm good to go. So again, you'll notice that these come down to very easy trig equations, which don't actually need much manipulation. Okay, now on the other side, we're going to do exactly the same thing. So 2 sine theta equals 1, so sine theta actually equals positive a half. So I'm going to set up my two different solutions. So I shift sine positive a half, and you get 30 degrees. And of course, adding your plus k360. And then again, 180 minus what is now 30 degrees. So let me write my note. Where does that come from? That's 180 minus 30. So again, I actually land up with 4 solutions because this splits into 2 linear equations. Now just going back to my steps, when it says, is this quadratic? If the answer was no, so if it was like a level 3 type, don't forget that that means you go straight to solve as normal. And we did the steps for solve as normal in the previous video. And those steps were things like isolate the trig ratio, do your shift sine or shift cos or shift tan, set up both solutions, and then solve for theta. So basically those are kind of our new steps that we've added in. Okay, so let's move along to question C. First question I asked myself, is this quadratic? The answer is yes, it's quadratic, which means I need to treat it like a quadratic equation. Now note for the first thing here is it's not in standard form. So I'm going to need to factorize, just writing down my steps here, but I need standard form first. Don't forget that in any in any quadratic equation, I can't spell standard, which is not helpful here. So let me try that again. In any quadratic equation, you need to have one side equal to 0, and then you can go factorize. So first what I would do here is I would say tan squared theta minus 3 tan theta plus 2 is equal to 0. Now I can factorize. Now, especially in an exam, if I didn't like this, change this in an exam to having an x instead of a tan, and actually go and factorize this, and then on your answer sheet you can just write down the factorized tan version. So what I'm doing in brown now, if you struggle with factorizing with trig, you just scribble this on your question paper. So I actually get minus 2 and minus 1. So in an exam, I would go straight from there to writing, great, so tan theta minus 1 and tan theta minus 2. And what I've written in brown, I would just use as scribblings on my question paper. Okay, this is great. This means that either tan theta minus 1 has to equal 0, or tan theta minus 2 has to equal 0. So there's two different equations now. Now the great news is that this is a tan equation, and tan equations are nice and easy. So that looks like TAM, so let me write a little bit better there. So basically here I isolate my trig ratio, I then do shift tan of 1 and I get 45 degrees, and the beauty of tan is that the second solution is generated by writing plus k180, and so both my solutions are built in there. This is why we love tan equations. And on the other side, if I isolate tan theta, I get tan theta equals 2. Now don't forget that sine and cos of theta cannot equal anything above 1, but tan of theta can, so this is not a problem. So tan, if I shift tan of 2, I get theta equals 63,43 degrees, and again the second solution is generated by writing plus k180. Now, just to write a note here, I mean, I wouldn't write this down, but just to say this, if this was a sine or cos, you often do a quadratic with sine or cos, and then you'll end up with sine theta equaling 2. And don't get a fright when you do shift sine of 2 and it says maths error, and that's because sine of theta can't equal 2. It can't be anything above 1. Now this often happens in quadratics, in which case you just draw a neat little line through that, and basically you're saying, well, sine theta can't equal 2, and so that part of the equation is now dead to me. Now I'm going to erase that because that's, you know, just an aside, but it often happens. Right, onwards. I see this, and the moment I see this, I'm like, oh, it's quadratic, which basically means I'm going to treat it like a quadratic equation. Make one side equal to 0, which has been done for me, and factorize. Again, if you don't like this factorizing, you can use x's, but this one's a fairly nice one in that basically the numbers are 1 and 4. 1 and 3. 3 and 1 make your first, you know, that's obvious, and then it has to be 1 and 1. There's no other option. So it's 3 and 1 and 1 and 1. So I don't have to check options, and as far as I can tell, they're both minuses. So make one side equal to 0 and factorize. So put my equal to 0. Right, now I can split this off into two different equations, and you can start cutting corners by not actually writing down, you know, it must equal 0. You can write, you know, you can go straight to something like that. So basically 3 sine theta minus 1 must equal 0, and there's nothing wrong with going straight to the answer of a third. Or sine theta has to equal 1. Now that's allowed, it just can't be bigger than 1. And now it's a fairly easy kind of sine equation. So I'm going to shift sine of a third, and I'm going to get my first solution is theta equals 19,47 degrees, and add my usual k360. Now, or the second solution for sine is 180 minus that answer, which in this case is 160,53 degrees. So again, just a note, where did that come from? I just used my answer button on my calculator and I said 180 minus answer. And then it's plus the usual k360. And on the other side, sine theta is going to have to equal 1. So if I do shift sine of 1, I get to 90 degrees. So I say theta equals 90 degrees. And then my second solution, interestingly enough, if I do 180 minus 90, guess what? I get 90 degrees. Now this happens when you have sine and cos sometimes equal to 1 or 0, depending on, generally it's 1 that this happens with. So notice that these two answers kind of coincide. So you don't have to write both. So this is the same thing, which means the moment I realize that, I kind of don't bother writing this because it actually is the same as 90. So here there's actually only 3 different solutions to that. Right, that's lovely. On to another one. Oh, now this is the first kind of next step up in the whole process, because the moment I look at this, again, oh my word, it is quadratic. And so I think make one side equal to 0, which I'm going to go and do. So I say 2 sine squared theta minus 3 cos theta equals 0. Done. Now my next step is factorize. And if I have a look at this, there's no common factor. It's not a dot, and it's not a trinomial. And so what it makes E different from everything else we've done so far is this is our first example where we have a mixture of trig ratios. Now I see this because I see sine squared and I see cos, which means I'm mixing. Now it's very, very rare that you're going to want to solve an equation with, you know, a mixture without getting rid of the mixture. And we will get to examples where you don't get rid of the mixture. So there's almost like 3 different types of equations where you have a mixture. And ultimately, my first thing is, can I get rid of the mixture? That's my first type of question to myself. Can I get rid of the mixture? Can I morph this into an equation that only has cos or only has sine in it? Now, in order to do that, I need to either get rid of the sine squared or I need to get rid of cos theta. And our first thing is look for the squared. And that's because sine squared is the same as 1 minus cos squared. So it is possible to change sine squared into something with cos squared, and vice versa. If you had a cos squared, it is possible to change this to 1 minus sine squared. And then the moment you have a trig equation with only one type of trig ratio in it, it makes your life a lot easier because it makes common factors and trinomials possible. So for example, here I would replace sine squared with 1 minus cos squared, because now I've gotten rid of my mixture. So that's my next step. The moment I see a mixture, can I get rid of the mixture? And the answer is look for sine squared or cos squared. That's my first kind of type. There will be other types, and we'll go over those, one in this video and then in the next video. But this is the first type of thing we look for. Can we trade out a sine squared for some version of a cos squared? Or indeed vice versa. Now I'm going to multiply out, and what do you know? That is looking more and more like a trinomial. The only problem is it's in the wrong order, and I've got a negative as a coefficient. So I'm going to divide everything by negative and write it in a better order for myself. So I actually get 2 cos squared plus 3 cos theta, and then minus 2. Now I can factorize. And again, if you struggle with factorizing, rather use x's. So I get 2 cos theta, and this is cos theta, and this is plus 2 minus 1. And now I'm back to what I have had, in questions A to D. So I've got 2 equations. On the one hand, I know that cos theta has to equal a half. And on the other hand, I know that cos theta has to equal minus 2. And the moment you write that down, alarm bells must go off. I know that cos can only range, so cos theta is an element. That's what that means. Cos theta is an element of -1 to 1. Cos theta can only equal something between -1 and 1. And as I said before, this happens often. And it's very nice because you just put a line through it, because this is not possible. So there's no possible solution that'll make that work, which is lovely because it actually means that I just have to carry on with one of these equations. So be very aware of that. It comes up a lot. So I'm just going to solve where cos is equal to a half. So I do shift cos of a half, which is 60 degrees. And the beauty of cos is that you write plus minus, and then it takes care of both of your solutions. So it's plus minus 60 degrees. K is an element of integers, and the other equation got you nowhere. So just to recap here, this is the idea that you don't want the mixture, and if you can trade out a sine for a cos, or vice versa, it's first prize. And so we look for the sine squared and the cos squared. So if I go down to these next examples, that's exactly what I'm going to do. So first things first, this is reduction. So now we're bringing in something else here. So these look weird, but just take them step by step, and they're actually not too bad. So let's practice our reduction. First of all, I ask myself what quadrant this is in. This is in quadrant 3, and sine is negative. But I'm working from 180 degrees, so my name does not change, and this is negative sine theta. Now my next problem looking ahead is this is a mixture. I've got 1 minus cos squared, and I've got a sine theta. I don't want a mixture. But the moment you see 1 minus cos squared, you need to start picking up these patterns. Hang on, 1 minus cos squared is sine squared theta. Now, if you didn't pick that up and you decided to change cos squared, that's fine. You could change cos squared to 1 minus sine squared. But look what would happen. You would have 1 minus 1, so it would disappear, and you'd have plus sine squared, which is that. So it doesn't matter if you didn't actually pick up the pattern and you just replace the cos squared. Oh, now we have a lovely equation, because I'm going to make one side equal to 0. That doesn't look like a 0. so used to drawing thetas, I'm going to bring my sine squared over, my sine over, just to keep my sine squared positive. Highest common factor, definitely, so highest common factor of sine theta, so I have sine theta plus 1. And now I have my two solutions. So either sine theta is going to equal to 0, or sine theta is going to equal negative 1. Now that's allowed. It's allowed to equal negative 1. It's not allowed to be less than negative 1. Now shift sine of 0 is 0. So I get 0 degrees plus k 360. K is an element of integers, so that's number 1. And my second solution here, so or if I do 180 minus 0, I get 180 degrees. Now, very importantly, when you get weird things like this, like 0 and 180, it's possible to write this answer differently. Now, there's nothing wrong with writing it like it has been. But when you see a memo in a test and you're like, but I didn't get that, how did they get that? Just have a look at, do you generate the same solutions if you like work them out? So have a look at this. From 0 to 180, if I add 180 to 0, I get to 180. If I add 180 again, I'll get to 360, which is 0 plus 360. So you can combine these two. Now this only ever happens when you have things like 0 and 180. So you can combine these two, the fact that theta could be 0 degrees plus k 180 degrees, simply because 0 plus 180 is 180. So this is an example very similar to tan, where the first solution can generate the second solution. But again, it's very rare. It only happens when your answers happen to be 0 and 180. Now on the other side, I did shift sine of negative 1, and I got negative 90 degrees. Now that's my first solution. So or my second solution is when you do 180 minus that. And if you do 180 minus that, you do 180 minus negative 90, which becomes 270 degrees. Now there's another interesting fact here. And again, if you wrote this down, you're not wrong, so I'd give you the marks. But you would look at the memo and you won't see this answer, and then you'll think that you're incorrect. Because what is negative 90 plus 360? Negative 90 plus 360 is 270. So I'm going to write myself a note here, but 1 and 2 are the same thing. And they're only the same thing because if you add 360, you get to the next solution. So here you don't have to write both. So I'm going to write because negative 90 degrees plus 360 is 270. Yeah, you'll notice that these weird kind of interactions happen when your answers are on the axis. So just have a look when your answers are axes whether there's anything funny. So in this case, you could not write that and your answer would actually be right, because negative 90 plus 360 would give you 270. And so again, the first answer automatically generates the second. Now don't be afraid of questions like that, because even if you left both answers, we wouldn't mark you wrong. It's just that when you look at a memo, you think that you're wrong and you're not. Okay, just a couple more. This is a fairly standard one now, so you might even want to hit pause, try question B, and then, mark it, see how you do. So what I would do, hopefully you've tried it on your own, is I would do 3 cos squared theta. Now don't forget that cos of a negative angle is just the same as cos of an angle, and so it's almost like that negative disappears. I would minus 1 on both sides. I would then factorize, so I get 3 cos theta, and this is going to have to be plus 1, and this is cos theta minus 1. So 2 answers here. So either cos theta is going to have to equal negative 1/3, or cos theta is going to equal 1. Now cos equations are quite great because you shift cos of negative 1/3, and I get 109,47 degrees. Plus the usual K360, and the way to make the second solution is to just say, well, it's the plus or minus version. So one line, which is really nice. Now, or when I do shift cos of 1, I get 0. And so 0 plus K360, the only thing is I wouldn't put plus or minus 0. because plus or minus 0 is just 0. And so again, this is almost like that same one with the sign. In fact, it is the same as the sign. Plus or minus 0, it's the same answer. So I only have to write 1. Now again, possibly try question C by yourself and see how it goes, and then watch the solution. So hopefully you've done that and done this by yourself. The moment I see, I'm like, it's quadratic, but I see a mixture. I don't want a mixture, so I change the sine squared to 1 minus cos squared. I'm now going to multiply out, and like I would a normal kind of quadratic equation, and then I'm going to get it in kind of a standard form, and then factorize. So this isn't particularly pretty. So if I add like terms and I divide by negative, I'd actually get positive 2 cos squared. Divide by negative gives me minus cos theta. Now 2, take away 1 is 1. But then I would divide by negative, so it's minus 1. Now if I factorize, that would give me 2 cos theta. And this would be cos theta minus 1. And now again, we get 2 equations. So this would mean that cos theta would have to be equal to negative a half, or cos theta would have to equal 1. Now we've just solved cos theta equaling 1. We just said that cos theta equals 1 means that theta is 0 degrees, and we chatted through the fact that plus minus 0 is exactly the same thing. So I'm going to leave that out. And shift cos of negative a half gives me 120, and so it's plus minus 120, and then the usual K360. So again, the trig part of these equations actually is not too bad, because they'll end up being fairly easy. Right, so far our mixtures have been fairly okay. We've looked for the sine squared and the cos squared and just replaced them. And now we finally get to this question, question D, which is a mixture, but it's a weird one, because it's a mixture, but there's no sine squared or cos squared. So there's no ability for me to replace a sine squared or a cos squared to get rid of the mixture. So my question becomes, how do I get rid of the mixture then? And so I'm now bordering onto what our next topic is going to be. But I thought I'd just throw one in here to kind of sow the seed. There's no sine squared or cos squared, so how do I get rid of the mixture? Well, what's the only other connection between sine and cos? There's one connection, and that's the idea of sine squared plus cos squared is 1. However, there's also the fact that sine theta over cos theta can be replaced with tan theta. So the question is, can I make this into sine theta over cos theta? And you get really used to this. Now what I would do is I would move the cos theta over, and I would make it negative cos theta. Now normally you're never allowed to divide by a variable in an equation because you lose a solution. But let me show you what I do here. If I divide by cos theta on this side, and I divide by cos theta on that side, you're actually not cancelling away the cos theta forever. What I'm doing here is my cos thetas cancel, so cos theta cancels and I get negative 1. But I haven't made the cos theta disappear. All I've done is I've put it on the other side of the equation. So I've kind of just moved its position. Just remember, you're never ever ever allowed to divide by a variable in an equation if it disappears, because then you lose a solution. But I'm not making it disappear here. I'm just writing it in a different place. Now, guess what sine theta over cos theta is? Sine theta over cos theta is tan theta, which is so exciting. So this is what we're going to be doing in the next video. My first port of call is look for the cos squared and the sine squared to get rid of the mixture. If that fails, look for sine theta and cos theta and try and make a tan theta. Now we'll discuss things to look out for in the next video. So this is just an intro. Now I haven't finished because I'm going to shift tan of negative 1 and I get negative 45 degrees, and when I add K180, that will automatically generate my second solution. So again, we'll discuss through questions like D in the next video when we look at level 5, which is exactly this, sine equals cos type equations. Cool, I hope those were fun. I really enjoy them.